All right, I'm going to do a little case study today. I'm going to talk about how we rethought about our infrastructure tooling at our company. I'll get into the details of that in a second. I am the CTO at Fairwinds. I'm an author and maintainer of a couple of open source products in the Kubernetes space. I'm involved in the CNCF, so I spend a lot of time working with different groups over there. And really, I've been in infrastructure and working with computers since I was a little kid. I got to build networks in my house with my dad to play StarCraft, and I really enjoyed that, and that just set off a lifelong love of making computers talk to each other. There's some contact information there. I'm happy to chat with anybody afterwards. And then I'll talk a little bit about Fairwinds. So we build, run, and maintain Kubernetes infrastructure for other people. We take away all of the toil of running Kubernetes and all the add-ons that you need to make Kubernetes work for you so that you can focus on business critical applications. What this means is that we solve some semi-interesting problems. At least I think they're interesting. We run dozens, if not hundreds of clusters. We're hoping to scale that up over time and run thousands of clusters. We do this across three main cloud providers, three big cloud providers. So we get to experience all the joy of that. Every one of the clusters that we runs in a different account or project or subscription, whatever cloud you happen to be in. They can be configured in many different ways because we're doing this not with our internal organizational structure, but we're building into our customers' infrastructure. And so they control the cloud environment. We just run the clusters. And so we have to be fairly flexible with how we do our tooling. We have a contractual obligation to provide infrastructure as code that builds the infrastructure to our customers when they leave us. This is something that is unique to us as an organization because we sell to other people. We want them to be able to leave. We don't want to lock people in to us managing their infrastructure. We want them to be able to take it when they grow out of whatever we do or if they want to change things up. And so we have to be able to give them that code that builds their infrastructure when they leave. We have fun authentication problems because of what I just said, running in lots of different other people's cloud accounts. We don't get to control all the authentication mechanisms. And so we have to think very carefully about where all the keys to all of the many kingdoms that we have access to live. And so this all drives how we build our internal tooling. Not all of these problems are unique to us. Many of these can be translated to how some companies run, some enterprises run. And so I think this talk can be relevant to folks that don't do it the way we do it. I just like to outline the interesting bits about what we do. So I called this rethinking our infrastructure tooling. What that really means is rewriting our infrastructure tooling. Why would you do that? I think the time-honored wisdom is that rewrites are bad. You should not rewrite things because it will always be more expensive than you think. And you're probably better off just spending the time and money improving the system that you have. So there's a lot of bad reasons that people go about rewriting things. Sometimes people rewrite things because they want to use something shiny. They see a tool, they see a process, they see something super interesting, and they're like, we have to do it that way because that's what everybody else is doing. And it's shiny and it's cool. Kubernetes used to be that thing. People would chase it because they say, oh, you should be running Kubernetes. So I think that's a terrible reason to rewrite something. In a similar vein, one engineer said, we have to do it this way. That's not a great reason to rewrite your whole stack. But there are, I think, many good reasons, not many. There's one or two good reasons to rewrite your tooling stack or even your software. And those are all driven by the business. Things like speed, agility, security, these are all driven by business demands. We want to be able to release features or make changes faster because it enables our customers to do X. That's a business story that we can tell. And I think it's super important as engineers and SREs and leaders in the technology space that we really tie that technology piece back to the business piece to make this decision. And did I mention that business is the only reason to do a rewrite? So for us at Fairwinds, at the end of the day, we couldn't push out changes to all of our customer infrastructure at a speed that would satisfy the agreements and the promises that we had made our customers. So if a CVE was released and we needed to patch something across the entire infrastructure, it took us longer than we would like and our customers would like to be able to make that change. And so we said, we really need to step back and rethink how we're doing this and decide on a path forward. So we went through what I'm going to detail as a fairly lengthy process here. I didn't write this process before we did it. We did all this, and then I went back and wrote the process. So this is encapsulating how we went through this process. So the first thing we did was really sit down and write down the assumptions that drove our existing solution. What were the decisions that were made that drove the design that we were currently using so that we could reevaluate those decisions and make sure we were making the right choices? The second thing we did was identify the problems that we have. Then we listed out the requirements for whatever it was we were going to do next. Brainstormed possible solutions. We picked one. That's a little bit of a question mark. We'll go into more detail about that later. We did one or more POCs, proofs of concept, and then we iterated a lot on various solutions. And then finally, we got to an implementation phase. I'm going to go into each one of these in more detail. But first, I'm going to talk about the existing solution. So we had a Python-based templating engine that would spit out all of the infrastructure as code that maintained our customer infrastructure. And it would create a repository for each individual customer. And it was built in a time when, and this was probably about 8 years ago that this stack was beginning to be built. And the engineers that we were working with at the time really wanted this interactive experience. They wanted to say, jump into a customer infrastructure and say, give me a new add-on over here, or update this add-on. And what this really evolved into was every time you had to make a change, you went into each individual infrastructure and you made a change, and then you made a pull request, and then you pushed it out. And that was really driven by the people we were working with at the time. That was 8 years ago. None of those people are still around except for me, and I don't count. We got to reevaluate that decision. There was a lot of fear around automation when it was originally built. They were worried that with great automation came the ability to break things faster. And so they intentionally slowed down the design of this. And so we really sat down and thought about, is that still the case for us? Do our engineers really still want to work this way? And the answer was no, they didn't. And so we got to rewrite it all. We identified the problems with that. I've already alluded to some of these, but it didn't allow for rapid changes. I couldn't make a single pull request and change the version of Ingress Nginx across every staging cluster in our environment. It just wasn't possible. It required that interactivity. Another piece that we identified that was super important was security around this interactive piece. In order to make a change to a customer infrastructure, I had to access the customer infrastructure. I couldn't separate the access concerns for those two things. Now, in our new solution, I'll get to in a minute, but we've split those apart so that you can make a change without actually needing to go into the infrastructure and have access to it. Another thing that we identified was the speed at which we were improving the tooling was basically zero at this point. It was a Python-based tool. Nobody on our team knew Python anymore, except for a couple of us. And so really the tooling was not being maintained. And so then not all the infrastructure as code we were maintaining was managed by the tooling. And so we started to get drift across our customers. And we started to see that we were making mistakes because somebody would go in and make a manual change that would break things. These are things that have happened to all of us, I think, at some point in our career. Not enough automation, things start to drift, things start to break. So from that, we were able to put together a final list of requirements. The first, we were going to keep Git as the single source of truth. We wanted infrastructure as code. That was a given. We do infrastructure as code. It's a good thing. We still have to be able to give our customers the ability to leave. This is one thing that really had to be driven home as part of the solution. That is a business requirement, and we are stuck with it for better or worse. We wanted to be able to do this incrementally and without any disruption to our customers. We decided that forcing our customers to migrate just because we were rewriting our tooling was not a decision we could make. So this had to be zero impact to our customers. We wanted the ability to detect drift and prevent drift going forward. And we needed that ability to make a single change across every single infrastructure all at once quickly. We still want approvals. We still want reviews of those changes, but we need to be able to roll that change out within less than a day, shall we say. And then we wanted to remove that interactivity requirement. We want to split the ability to access the infrastructure from the ability to make changes to the infrastructure so that in the future, as our teams grow, we can split responsibilities and we can change the access model for people, how they get into the infrastructure. And this isn't required, but I found this to be a really helpful thing that we did. We wrote a goal statement. So I wrote this sentence and I ran it by the team, and the team all approved it and said, this is the goal of what we're doing here. And we were able to put this at the top of the design document, put it at the top of our various communications about this. And so we were able to rally around this single goal as a team. And I think that was super helpful as part of our process. All right. So we've identified the problem. We've reevaluated our previous decisions. We have written down all of our requirements. Now, how are we actually going to change this thing? What are the ideas that we have? Don't try to read this. It's not intended to be read. This is just a picture. And I'll get into more detail about what's on it in a second. But I'm a very visual thinker. And so Excalidraw is my tool of choice. I very often in meetings just jump into Excalidraw as a whiteboard. And so we started this document. It looked very different in the beginning, and we just threw out all the different ideas that we had for how could we do this going forward. No assumptions about reusing our existing tools, no assumptions about what tools we might use, just throw all the ideas down. And what this coalesced into was 3 separate patterns started to emerge. So we were able to identify 3 overarching patterns of infrastructure tooling that we could use to satisfy all of our requirements. And this was super helpful for me thinking about the decision space and really getting out of the habit of looking at individual tools. We were like, oh, let's use Spacelift. Spacelift is a tool. It doesn't really dictate how you use it. And so it's not an architecture pattern. It's not a way to design our tooling. And so we really defined these 3 different patterns. So I'm going to go in, and then we took those and we defined pros and cons of each one. And again, that goal statement is at the top. We used it to drive all of our decisions. So I'm going to go into the 3 different patterns that we looked at and talk about the pros and cons. Not because I think it's super important what the individual pros and cons were for us, but I think it shows the thought process and how we thought about each solution, meeting the requirements that we had, and then, the challenges that it might present to us as a business. So the first solution that we identified, the possible pattern that we identified, was to double down on how we were doing it now and improve the way we were doing it now. So this solution is, let's keep the individually templated out infrastructure as code repository for each customer, but let's improve the automation. Let's change the way we do that templating. Let's do something slightly different, but really double down on the current pattern. So there's several pros to this. We have that ability to make changes quickly if we do the automation right. It's very easy to move to this solution because we already had individual infrastructure as code repositories for every customer. So we just had to adopt those into the new tool or whatever we decided to do. It has the ability to do rapid overrides, as we call it. So you can go into an individual customer's infrastructure as code, make a change at 2 a.m. because you got paged about it, and then adopt it back into the tooling later when you're actually awake. It separates the blast radius to each individual customer. We have this middle step where we template the repository, that makes a pull request, and then you get to approve that individual change to each customer. And it was a familiar pattern to us, which I think is super valuable because we don't have to re-educate the entire team on how the tooling works. They know this pattern. Now we're just adding in additional automation. Some of the cons, if we decided to stick with our current tool set, it was written in Python. And this is at a time when we were deep in Kubernetes. We had a bunch of open source, and all of that open source was written in Go. Kubernetes was written in Go. All of our team knew some level of Go, and almost none of them knew Python. And so one thing that I'll talk about more later is being super mindful of the skill set that your team has when making these kinds of decisions. I'll talk more about that later. But another con, that sort of 2-step process, that middle layer can be a little bit clunky, a little bit weird to get your head around. And if we didn't succeed in automating, if we didn't get all of this in automation, we were going to be back in the same boat we were before, and we were going to have the same problems we had. So that was a risk. The second solution that we came up with was remove that middle layer and run infrastructure as code in a more traditional way. We would have a huge stack of infrastructure as code of some kind, Pulumi, Terraform, something like that, and that would directly manage all the customer infrastructure. That's One of the pros is it's a single code base. We don't have these two layers. So it's a little bit easier to wrap your head around. Changes could definitely be made in one place across all the infrastructure if you design it correctly. It could potentially make it easier to do ephemeral clusters or build new clusters faster, because it'd just be copying and pasting one stack or just adding another values file or something like that. So that was one potential pro. It's higher risk. You do have the ability to directly make a change that breaks every single customer all at once. And, that's a little bit scary. We have a little bit of a problem with this design in that how do we give our customers the code when they leave? If it's one centralized thing that manages all the customers, it's a little bit trickier to think about how we would do that. We had some ideas about how it might work, but it was not as cut and dry as just transfer a GitHub repository to them and say, have fun. We might end up with a giant monolithic infrastructure as code, which could be a bit difficult to manage if it gets too big. We're not smart about how we build it. It centralizes all the access to all the customer environments into one place, which can be higher risk as well from a security perspective. And then another con to this, we couldn't give customers access to it while they were working with us, because it would have all the customers in it and we can't share it. With the individualized infrastructure as code repository, we were able to say, you customer can have access to your individual thing. So that was, from our business's perspective, an important thing to think about. The third potential solution was to really just shift the paradigm entirely. Let's go and use Cluster API, use something that supports Cluster API, and build all of our clusters with something like Crossplane or Rancher or whatever. Tooling, again, not super important here, but the paradigm being we would have a centralized control cluster, and then we would have custom resources that would define the customer infrastructure. This, I'm just going to jump through these relatively quickly, but one pro, it's Kubernetes native. We're a Kubernetes company. We all know Kubernetes, so that's cool. It doesn't really require anybody learning a new programming language, unless you consider the complexity of Crossplane a programming language, which it might be. It would be very easy to create new clusters, test clusters on the fly really fast, because it's just creating a new custom resource. One con would be we'd have to maintain more internal infrastructure. We do that a little bit already, but we couldn't really, it would make the maintenance of that a little bit more complex. We'd be introducing a new, potentially very complex third-party application like Crossplane. We ran into some issues during a POC of outdated and missing weird providers with Crossplane, whereas when we were just purely using Terraform and Argo CD, everything was pretty much available to us. All the Terraform providers are there. They all do all the things we need them to. And really, the big issue with this one, I think, was just the massive level of complexity and change from what we were doing previously. And so quite likely, it might have resulted in us needing to migrate customers, and it would have been an extremely expensive change to make. While it's technologically the coolest solution on the board here, and probably the most fun from like a tech nerd perspective, like I totally got nerd sniped by this, it really was the biggest shift for us as a team, and so was a very expensive solution, something to think about. That was the brainstorming phase. Then we had to make a decision. And in order to make that decision, we did some proofs of concept. We were leaning in one direction. You can probably tell already by the way I've been talking about it, which one we picked and which direction we went. But this part is really dependent on how much time and money you have to spend on doing POCs. POCs are potentially expensive, potentially lengthy. They take away from engineering time. And so we really only had enough time and space to try out a couple of these at a very low level. We weren't able to spend a lot of resources on this. And so we really made a decision at this phase. But I think proofs of concept are super valuable. We did do a couple of them. So I'll talk about them briefly and some things some rules we put around proofs of concept. So they have to be time boxed. You can't let them run for 6 months. It's just not something anybody has time for, I don't think. And then there's a little bit of an art to picking how much POC you do. And you can either do the full implementation, which is no longer a proof of concept, it's a proof of implementation. And that's too far, but you can't do too little as well, because if you don't spend enough time to really prove that the solution will work, you won't find those rough edges that you need to hit that will potentially cause that solution to not work for you. And so you have to take it just far enough. So the last step is to iterate. We eventually chose the first solution, which was doubling down on what we did. We removed the entire Python stack and replaced it with Terraform, which is funny. We have Terraform generating other Terraform. It's a weird solution, but it fit all the requirements that we had as a company, and it didn't require us to relearn any new tools. So that what was sketched on that first slide, the one that I told you not to read, what was laid out there is basically what we ended up doing. But it has changed quite a bit, and don't be afraid of that. It's going to change. That's okay. I think we're all comfortable at this point with the concept of build something small, do an MVP, and then iterate on it. So I don't want to spend an overwhelming amount of time telling you all how to do Agile, because I don't think we need that here. A couple other things, getting buy-in. This whole process was driven and owned by me, but it also involved every single member of the team at just about every phase. That brainstorming document was created as a team. The design document that was generated from it after was also generated by the team, commented on by the team. And so by the time we got to the implementation phase, everybody was already sold. There wasn't going and convincing other folks that this is how we're going to do it going forward. Everybody was already involved and everybody had made that decision. If you have the ability to get everyone involved like that, do it, because it makes the later phase much easier. And it's still going to take longer than you think. We designed it last year. We're probably about 80% of the way through it. We did build it in a way that we can implement pieces of it at a time and slowly iterate it through that. That was great. I prefer that to hard cutovers if you can avoid it, but it's not always avoidable. But just be ready. It's going to take a lot longer than you think it's going to. Just a few last tips and tricks. I talked about this earlier. Don't pick tools before you've picked patterns. You can use tools to inform what patterns exist and how you might do things, but don't try to choose a tool. Choose a design instead. And don't design aspirationally. We all want to do something really cool and really fancy. I really wanted to write everything in Pulumi because I actually love working with Pulumi and Go, and none of the team was comfortable with that level of infrastructure as code. And so we chose to stick with Terraform. And lastly, keep it simple. The solution we ended up with is simple. It is not super complex, but it works really well for our use case, and we've gained a lot from it. And then lastly, mind your team strengths. I've said it over and over again here, but thinking about what your team can do, not what you want your team to be able to do, or budget for upskilling the team, right? If you have the time and the money to teach everyone how to write Pulumi, and go for it. But we did not have that. So that's it. Anybody have any questions? Oh, we got a mic.
Oh, yeah. Just generally curious, how long did you time box it for your POCs?
We tried to keep them to a week or two. That's driven by the complexity of the solution. If I could make them a day, I would.
Well, yeah,
but
just
it just depends on, ours were about a week or two. Yeah.
Hello. Can you hear me?
Yeah.
How long did the entire process take from the ideation to the release of your product?
From ideation to what?
Release of your product, the code change.
Oh, like I said, we're still not done with it, but from ideation to really beginning the implementation and really getting a full head of steam on the implementation was probably about, I think it took us 3 or 4 months. It was a long process. It was done within all the other work we were doing, and it took quite a while.
Hello, thank you. It was very interesting. You mentioned that you needed a buy-in. Can you share, being CTO, who you needed to sell this idea to?
The whole team, the engineering team that was going to be using the tooling, is really who I had to sell.
So basically, you wanted to sell it to the users of the tool, right?
Yep. Yeah, because they're the ones that have to use it. And so if they weren't, now, I think I forgot to add this part, but they're the ones maintaining it now too, right? I'm not a sole developer to keeping the thing running. We wanted the team to be bought in, not just on using it, but adapting it going forward. And so it was really getting them on board with that pattern. And now before we had almost no activity on our tooling repositories, and now every single member of the team commits to it almost on a daily basis, which is a huge shift for us, and it's been really good.
Out of curiosity, was that from a top-down perspective or a bottom-up perspective as far as the buy-in goes? Or both?
It's a little bit of top down and then convincing people it was bottom up. A little bit of an inception, really. It was, hey, what if we did this differently? And then here's some ideas, and then helping draw that out. But this one really started top down.
And out of curiosity, of Terraform, have you guys looked into, was it Terrafoki or something like that? The open source version of Terraform?
Oh, Open Tofu?
Yep.
We have not moved to Tofu yet.
But they've been bought. So I think they've been bought by IBM. So maybe there's hope.
Yeah, I have no idea. That
Either confirm or
whole
deny.
space is a mess.
Sure.
What's funny is right as we decided to do this is like the week that HashiCorp changed the license, the timing was really awful. And so that we actually ended up using Atlantis open source to run all of our Terraform and building out that stack ourselves to avoid some of the risk of using another provider. And Open Tofu was just a sparkle in someone's eye at that point. And we will most likely end up moving to Tofu. The momentum of that community and the buy-in has been really good. And I've seen a lot of positive signs there, but we have not yet.
Yeah. It could very well be another, a CentOS thing. So we just don't know.
Yeah.
So we just don't know. The other thing too is like for static, do you do most of your Go stuff in static, or basically you're doing dynamic libraries? And what's your thoughts on Rust?
Those are some interesting questions. So we didn't do anything in, oh, you mean all of our open source in Go? It's all static. Yeah, we're using all static binaries with our open source, yeah. And I have no thoughts on Rust at the moment. I've heard good things, but yeah, no thoughts at the moment.
All right.
Last one question.
You mentioned you were developing this as part of your go-to-market or your customer solutions, and getting authentication and isolation right was important as part of the project. Did you have to provide any level of assurance to customers as part of this project, or will you?
Not as part of this project. That was actually something that had already been solved as part of the previous stack. So we had built out a full authentication management setup through Vault, and we'd been running that. And so this solution is compatible with that. It was a separate concern. To our customers, this was almost invisible. They basically didn't know it happened.
Thanks, Andrew.
Thank you.